Okay, I have to tell you I'm very tired, but this week is difficult, week 5. Don't rush, which doesn't mean upload the homework in week 10. But if you can take a few more days until you understand everything, please do. So I chose this, hopefully this is recording. Um, so I chose this site because it's probably the easiest that I found. So to get you at least on the ABC of vectors. Now vectors is a quantity that has magnitude and direction. I'm not saying or it could. A vector has both. They're intricate, they're embedded, they are properties of a vector. It is not a vector if it doesn't have both. So magnitude basically means how big the vector is, and direction is at what angle, if you put the beginning at the origin, at what angle. An angle is by the means of trigonometry that we already know. At what angle is that vector? That will give you the direction. And here at the next drawing, you see how the direction is where the arrow points, and the magnitude is simply how big the vector is. So there are several ways of adding vectors. You can add them geometrically and you can add them algebraically. When you are adding vectors, they have to be arranged head to tail. So you see here's the beginning, in other words, beginning, end, beginning, end. You cannot add a vector with the arrow pointing this way. So this is very important. You can add 2 vectors, you can add 10 vectors, and their order doesn't matter, although the drawing is going to look different, but the end result is the same. So if you add a plus b or b plus a, doesn't really matter. It might look again slightly different, but the result is going to be the same. Now notice vector a plus b is the same length in both cases, and it points to the same direction. Very important. Now here you have some more example, and it's usually boat going on a river or airplane in the air are the same questions, kind of using the same concept of addition of vectors. Yes, you're going to have some word problems later on. Now, subtracting should be looked like addition, but with a negative vector. Negative vector. It means the direction is opposite. That's what negative indicates. So right here you have b, vector b, and vector negative b. As you see, it's the same general direction, but opposite. You're going into the other direction. Look where the arrow points. Okay. So adding a plus negative b or adding a plus b, it's not the same. But you should use addition because the subtraction otherwise might confuse you. So you want to add a, and you're adding either b, depending what the problem is, or you're adding negative b. But notice how the negative is put so that it's arranged again hand to tail, except the vector is negative b. So you're adding negative b, which is the same like subtracting a and b. Be careful with that. That's a little detail, but it is important. Again, convert everything to addition so you can arrange the vectors head to tail, but you might then be adding negative b. So the notation for magnitude is And you see here the tail and the head are marked, so you would know which one is which. Again, you want head to tail, head to tail. They have to be arranged this way. The two arrows cannot be pointing toward each other. The magnitude, so sorry, it's probably somewhere. What I wanted to talk about next is right here. The magnitude of a vector, it looks like absolute value, doesn't it? And here you can have 2 to indicate the same thing. I don't use either, so it's kind of clear that I'm talking magnitude. But if it helps you, you can put those signs around to indicate the magnitude. So how do you find the magnitude? It's square root of the x component squared plus y component squared. Okay, so now let's go and see first what components are. Okay, so here are the components. So if you imagine this vector A at the origin, AX and AY are the components. So it forms something like a Pythagorean theorem, okay? It's a right triangle, and you can use the Pythagorean theorem, although those are vectors, but for the magnitude, we're talking magnitude. So that is going to be some kind of number. Now, as I said, you can add them geometrically, head to tail, or you can add them algebraically. So here it says the vector 8, 13 and the vector 26, 7 add up to this vector. So let's see how, okay? When you are adding algebraically, you have to add the x. It's actually, that is pretty easy concept as long as you don't mess it up. You have to add the x components and you have to add the y components. So if one of the vectors is 8, 13 and the other one is 26, 7, then you have to add 8 plus 26, that will give you 34. And then you have to add 13 and 7, which will give you 20. Do not add them. I mean, do not add after you find the sum of the x component and you find the sum of the y components. Do not add those two, okay? It is still a vector, so you're going to have a comma between them. So you're adding again the x component, you're adding the y component, but then the plus sign disappears and it is now a comma because the result is a vector. Again, easy concept, but try not to mess it up. So here again you have the components. So here is your actual vector. The dark red is your actual vector AB. And the perpendicular here is the y component, and the horizontal one is the x component. So again, as I said, subtracting is the same as addition, but with the negative vector, which changes only direction. So you already saw how to make the magnitude, how to write the magnitude. Is the x component squared plus the y component squared, and all that square rooted. Now you have to get familiar with scalar and vector. Scalar is something that has only magnitude. In other words, it's a number. And the vector, I'm repeating this because people always forget that the vector has both. So if you're asked to find the vector, you can't just find the magnitude. You also have to find the direction angle. Keep that in mind. And some of you might be wondering, is there something like a zero vector? Yes, there is. It's a little bit of a strange concept because the zero vector doesn't technically have a direction, but it does exist. It is introduced as a convenience and it does exist. Now, there are several ways you can multiply vectors. That's a little bit more difficult concept. Now, if you're just multiplying by a positive number, it's going to get that much bigger. The vector is going to get that much bigger. Now, if you're multiplying by a negative number, you're also changing direction in this case. Now, when you're multiplying a vector by a vector. There are two ways to do that. One is called dot product, one is called cross product. We're not going to be studying the cross product because this one requires third dimension and matrices, which I'm assuming you do not know. So we're not going to study the cross product. We're going to concentrate on the dot product. I would tell you that physicists do not call it dot product. This is mathematicians because they care more about the sign there that you use. The physicists call it scalar product. And it's very useful because you know that you have to get a scalar. Yes, you're multiplying two vectors, but you're getting a scalar at the end. So I hope this is recording. You can tell how slow my computer is. And here is the dot product. So it's called dot product because it has that dot compared to the cross. So that's very different when it comes to vectors. So what is the formula? It is the magnitude of A multiplied by the magnitude of B multiplied by cosine between them. This is the formula for dot product or scalar, as I said, like physicists do it. So see what is happening. Multiplying the x components. Now you have the plus. This plus, people always forget. Now when you adding vectors, you didn't have that plus anymore. It became a comma. Once you add the x component, then comma, then you add the y components. Now here, when you multiply the x components, you add the multiplication of the y components. Be very careful with that. Very, very common mistake that students make. So if you have, of course, and notice this is not an angle with the x-axis or with the y-axis. This is the angle between them. And that's how you calculate scalar product. Or you can calculate also the angle between those two vectors. You just have to solve for the cosine theta. And here it's explaining why, if you're interested in learning why and how more. Now we're not going to study more than two dimensions, so really not worth here. Now I was going over this just to make a point, but you can find any tutorial on vectors. Just be careful with formula. You also have it, of course, on the PowerPoint. And I just uploaded some other videos of people who are talking about that. And I hope you're fine. And I hope you will take your time. Remember, there is a discussion due week 5. And I'm going to close it down as soon as week 5 is over. So you will not be able to post after that. So I suggest any time that you have right now, go and read the directions and answer some questions on the discussion board. See ya.